Welcome to our GCSE Geography lesson, making learning and revision simple. Today's lesson is on climate change and coastal futures. In this lesson, we are going to bring together many of the ideas from the coastal landscapes topic. So far, we have looked at coastal processes, erosion, transportation, deposition, landforms, sea level change, and coastal management. Today, we are going to think about the future. Climate change is making coastal management more difficult. Sea levels are rising, storms may become more intense, and some coastal communities are already facing difficult decisions about whether they can realistically be protected in the long term. The coast is not a fixed line on a map. It is a dynamic system. Waves, tides, currents, sediment movement, weather, geology, ecosystems, and human decisions all interact. Today's key question is, how can coastal communities prepare for a future of rising seas and increasing risk? We will look at storm surges, sea level rise, coastal ecosystems, hard and soft engineering, managed retreat, adaptation, and mitigation. Let's begin with the learning objectives. By the end of this session, you should be able to do 4 things. First, you should be able to evaluate the effectiveness of different coastal engineering strategies. That means looking at both strengths and weaknesses. For example, seawalls may protect valuable land, but they are expensive and can damage natural coastal processes. Second, you should be able to predict how global warming will impact future sea levels. We will look at the 2 main causes of sea level rise: thermal expansion and melting land ice. Third, you should be able to analyze the threat of storm surges to habitats and communities. Storm surges can cause sudden coastal flooding and can overwhelm defenses in a very short time. Finally, you should be able to discuss the interaction between physical processes and human management. This is the big idea for today. Humans try to manage the coast, but physical processes do not stop. Waves still erode. Longshore drift still moves sediment. Sea levels still rise. So management has to work with these processes, not simply pretend they can be controlled completely. Before we go further, let's look at the key vocabulary. The first term is storm surge. A storm surge is a temporary rise in sea level caused by low atmospheric pressure and strong winds. Storm surges can push seawater inland and cause serious coastal flooding. The second term is resilience. Resilience means the ability of a community or ecosystem to recover quickly after flooding or another hazard. A resilient coastal town might have good warning systems, flood plans, strong defenses, and buildings designed to cope with flooding. The third term is mitigation. Mitigation means actions taken to reduce long-term climate risks. In climate change, this usually means cutting greenhouse gas emissions, such as carbon dioxide. The fourth term is adaptation. Adaptation means adjusting infrastructure, buildings, planning, and daily life to cope with climate change impacts that are already happening or expected in the future. A simple way to remember the difference is, mitigation tackles the cause. Adaptation tackles the impact. The slide asks a powerful question. What if the map of England changed forever? This is not just a dramatic idea. Coastlines do change. They have always changed because of erosion, deposition, and sea level change. But climate change may speed up some of these changes. In the past 100 years, sea levels have risen by about 20 centimeters. That may not sound like much, but even small increases in sea level can make coastal flooding and erosion worse, especially during storms. If the rate of sea level rise increases, some places may become much harder to protect. The slide mentions places such as Fairborn and Haysborough. These are examples of communities facing difficult questions about the future because of coastal erosion and flood risk. The key point is, coastal management is no longer just about holding the line. It is about deciding what we can afford to save, what we should protect, and where we may need to adapt. These decisions are not just physical. They are social, economic, political, and emotional. Before we go further, let's recap some coastal engineering strategies. Question 1. Which hard engineering method consists of large boulders placed at the base of a cliff to absorb wave energy? Question 2. What is the primary disadvantage of using groins to protect a beach? Question 3. Which strategy involves allowing the sea to flood low-value land to protect more expensive areas? Take a moment to think. Remember, hard engineering uses artificial or built structures to control coastal processes. Soft engineering works more with natural systems. Managed retreat. also called coastal realignment, accepts that some areas may be allowed to flood in order to reduce risk elsewhere. Let's go through the answers. For question 1, the answer is rock armor, also called riprap. Rock armor involves placing large boulders at the base of cliffs or seawalls. These rocks absorb and dissipate wave energy, reducing erosion. For question 2, the main disadvantage of groins is that they can starve beaches further down the coast of sediment. Groins trap sediment being moved by longshore drift. This builds up the beach on one side, but areas further along the coast may receive less sediment. This can increase erosion elsewhere. This problem is sometimes called terminal groin syndrome. For question 3, the answer is managed retreat or coastal realignment. This involves allowing the sea to flood low-value land, often to create salt marsh or reduce pressure on hard defenses elsewhere. These strategies all have benefits and costs, which is why coastal management is never simple. Now let's look at why the sea is rising. There are two main reasons. The first is thermal expansion. As global temperatures rise, the oceans absorb heat. When water warms, its molecules move more and take up more space. This means the same amount of water occupies a larger volume. That expansion raises sea level. The slide says thermal expansion accounts for roughly half of the sea level rise seen today. The second reason is ice melt. Water that is locked away in land-based glaciers and ice sheets, such as those in Greenland and Antarctica, melts and flows into the ocean. This adds new water to the sea. It is important to remember that melting land ice is different from melting sea ice. Melting land ice adds water to the ocean. Melting sea ice has much less direct impact on sea level because it is already floating. So the two main drivers of sea level rise are warmer water expanding, land ice melting, and adding new water to the ocean. Now let's look at storm surges. Climate change does not just raise the normal sea level. It can also make some coastal hazards more dangerous by increasing the energy in weather systems. A storm surge happens when sea level temporarily rises because of low pressure and strong winds. Low atmospheric pressure can cause the sea surface to rise slightly. At the same time, strong winds can push seawater towards the coast. If this happens during a high tide, especially a spring tide, the water level can become extremely dangerous. Storm surges can overtop sea walls and flood coastal areas very quickly. The slide mentions the 1953 North Sea storm surge, which killed over 300 people in England. This was one of the most serious coastal flooding events in modern UK history. Today, London is protected by the Thames Barrier, which is designed to reduce the risk of tidal flooding. But as sea levels rise, existing defenses may come under greater pressure. A defense that worked in the past may not be enough in the future. Now let's sequence the events that lead to a coastal storm surge flood. The stages are: sea defenses are overtopped, leading to inland flooding. The surge coincides with a high spring tide, increasing the height. Strong gale force winds push the raised water towards the coast. Low atmospheric pressure causes the sea level to rise slightly. Think carefully about the order. First, low pressure raises the sea surface. Then strong winds push the water towards the coast. If this happens at the same time as a high spring tide, the total water level becomes even higher. Finally, sea defenses may be overtopped, and flooding occurs inland. The correct order is: first, low atmospheric pressure causes the sea level to rise slightly. Second, strong gale force winds push the raised water towards the coast. Third, the surge coincides with a high spring tide, increasing the height. Fourth, sea defenses are overtopped, leading to inland flooding. This sequence is important because it shows that coastal flooding is often caused by several factors combining. A storm surge on its own can be dangerous. A high tide on its own can be normal. But a storm surge during a high spring tide can be extremely dangerous. If sea levels are also higher because of climate change, then the risk becomes even greater. Now let's look at coastal ecosystems. Coastal habitats such as salt marshes and sand dunes are extremely important. They are not just places for wildlife. They can also act as natural coastal defenses. Salt marshes can absorb wave energy and store floodwater. Sand dunes can protect inland areas from wind, waves, and storm flooding. However, these habitats are at risk from something called coastal squeeze. As sea levels rise, coastal habitats naturally try to move inland. But in many places, They cannot move because there is a sea wall, road, town, railway, or farmland in the way. The habitat becomes trapped between the rising sea and human development. This is coastal squeeze. Over time, the habitat may shrink or disappear. The slide gives the example of the Essex salt marshes, which provide important breeding grounds for birds but are shrinking because of this pressure. So climate change and human structures can combine to damage natural ecosystems. Now we need to think about the big challenges facing coastal management in the 21st century. The first challenge is economic cost. Seawalls are very expensive. The slide says they cost roughly £5,000 per meter. That means protecting every mile of the UK coastline is financially impossible. Governments and councils have to make difficult decisions about where money should be spent. The second challenge is social justice. Who decides which village is protected and which is not? If one community is defended and another is allowed to erode or flood, people may feel abandoned or treated unfairly. This can create climate refugees within the UK, people who are forced to move because their homes are no longer safe. The third challenge is environmental impact. Hard engineering can damage the natural beauty and biodiversity of the coast. Seawalls, groins, and rock armor can interrupt sediment movement and damage habitats. This can also affect tourism if the coast becomes less natural or attractive. So coastal management is not just about engineering. It is about money, fairness, ecosystems, and long-term planning. Now let's compare adaptation and mitigation. We cannot stop sea level rise instantly. Even if emissions were reduced quickly, some future warming and sea level rise is already locked in because of past emissions. So we need adaptation. Adaptation means adjusting to the impacts of climate change. Examples include building flood-resistant homes, improving warning systems, creating flood storage areas, restoring salt marshes, and designing infrastructure that can cope with flooding. The slide mentions amphibious homes. These are homes designed to rise with floodwater or cope better in flood-prone areas. But adaptation is not enough on its own. We also need mitigation. Mitigation means reducing greenhouse gas emissions to slow the rate of global warming. This could include switching to renewable energy, improving energy efficiency, protecting forests, reducing fossil fuel use, and changing transport systems. A useful way to think about it is, adaptation helps us cope with the climate change already happening. Mitigation reduces how severe future climate change becomes. Both are needed. Now let's test your thinking. The statement says, managed retreat is always the best option because it is the cheapest for the government. Is that true or false? Take a moment to think. Managed retreat can be cheaper than building and maintaining hard defenses in some places. It can also create new habitats, such as salt marshes. But is it always the best option? What if the land contains homes, power stations, farmland, roads, or important cultural sites? What about the emotional cost of people losing their homes? What about compensation? So we need to be careful with the word always. The statement is false. Managed retreat is not always the best option. It may be suitable in low-value areas where the cost of defending the land is higher than the value of what is being protected. It can also be environmentally beneficial because it can create salt marshes and natural flood storage. However, saying it is always best ignores the social and economic costs. If people lose homes, businesses, or farmland, the impacts can be severe. If the area contains important infrastructure, such as power stations, transport routes, or water treatment works, retreat may not be realistic. The correct explanation is, it ignores the huge social cost of losing homes and the economic value of assets like power stations or farmland. A strong GCSE answer should always consider economic, social, and environmental factors. The correct answer is B. It ignores the huge social cost of losing homes and the economic value of assets like power stations or farmland. This is a key idea in coastal management. The cheapest option financially is not always the fairest option socially. And the strongest engineering option is not always the best option environmentally. Coastal management involves trade-offs. A seawall might protect homes, but damage the beach. Groins might build up sediment in one place, but increase erosion elsewhere. Managed retreat might create habitats, but force people to move. That is why decision-makers often use cost-benefit analysis, environmental impact assessments, and shoreline management plans. Now let's bring together the whole coastal landscape series. The question is, how do physical processes like erosion and sea level rise interact with human structures to shape our coastlines? Physical processes are always active. Waves erode cliffs through hydraulic action and abrasion. Longshore drift moves sediment along the coast. Deposition creates beaches, spits, and bars. Sea level rise increases the reach of waves and raises flood risk. Storm surges can overtop defenses and flood inland areas. Humans then intervene. We build seawalls, groins, rock armor, flood barriers, and drainage systems. But these interventions can change natural processes. For example, groins trap sediment and protect one beach, but may starve beaches further down the coast. Seawalls reflect wave energy, which can increase erosion at their base. Hard defenses may stop habitats moving inland, causing coastal squeeze. So the coast is shaped by both physical processes and human decisions. The future of coastal management may involve less fighting against nature and more working with natural systems. You might have said that physical processes like erosion and tides constantly challenge coastal management. That is correct. You might also have said that human intervention can cause unintended effects, such as sediment starvation elsewhere. That is also important. You might have said that climate change may exceed our current engineering capacity. That is a strong point because sea level rise and stronger storm surges may make existing defenses less reliable. You might also have said that future strategy may shift from fighting nature to working with systems. A strong GCSE answer might say, physical processes such as erosion, longshore drift, sea level rise, and storm surges constantly reshape the coastline. Human structures such as sea walls, groins, and rock armor can protect valuable areas, but they can also disrupt sediment movement and increase erosion elsewhere. As climate change raises sea levels, some defenses may become too expensive or ineffective. Future coastal management is likely to involve more adaptation, managed retreat, and working with natural systems such as salt marshes and dunes. That answer is strong because it links processes, management, and future change. Let's finish with the main message of the lesson. The coast is not a static line on a map. It is a dynamic system in constant change. Waves, tides, currents, sediment, storms, sea level, and human structures all interact. Climate change is making these interactions more urgent because rising sea levels and storm surges increase the risks to coastal communities. But the future is not only about danger. It is also about choices. We can choose where to defend. We can choose where to adapt. We can choose where to restore natural habitats. We can choose to reduce emissions and slow future sea level rise. The challenge is to manage coastal change with both science and empathy. Science helps us understand the physical processes. Empathy helps us recognize that coastal management decisions affect real people, homes, livelihoods, and communities. That is the future of coastal geography. Before we wrap up, if you found this video helpful, then like and subscribe to our channel for more content like this. Your support means a lot and helps us continue creating valuable videos. Thanks for watching.